Okay, great. Uh, so this training is about FHIR. As you all might have seen flyers from Shrinivas. This training is going to include or would include two parts. One is looking at FHIR, understanding the healthcare data standard, and start from zero. If you are very new to FHIR, you will get to know everything from zero till at least the intermediate level of how we can use FHIR in our regular implementations. And then in the second part, you will go ahead and we'll go ahead and talk about how do we practically construct FHIR resources, either by using an HL7 message or if you want, you can also connect to a database and construct your FHIR resources. We'll be looking at the most famous industry standard, which is HL7 to FHIR conversions. We'll take a look at the process, and we'll also take a look at how do we build those channels within Mirth integration engine. So that would be the second part of the training. So my name is Dickson. I'm technical lead and uh, have been training people online for a very long time now. I have 15 years of experience in healthcare industry, and I have worked on various healthcare standards like HL7, CCD, FHIR, IHE, and so on. I also have exposure working on various integration engines like Rhapsody, Mirth Connect, Integration Buddy, Ensemble. And as I said, I've been teaching people from past 7 to 8 years now, specifically in healthcare domain, and more specifically into healthcare integration space. So what are we going to take a look at by end of today's session? We will see what is FHIR. We will see where do we use it. We'll also take a look at how the name has been coined. We'll also take a look at the history of FHIR to get some understanding how it all started and where it started, where we are today. So when we talk about FHIR, we need to go back to the actual problem. FHIR is a solution to one of the major problem that the industry standards have seen back in 2010. So let's look at the problem first and understand how FHIR is going to solve that, and then we will jump further in detail into FHIR. So to begin with, FHIR, uh, uh, we know that whenever a patient visits the hospital, he'll go to the receptionist. They will provide their demographic details, they will provide their appointment details, and so on. And then the receptionist would schedule, first capture the demographic details, save that to the system, and then you will have appointment detail that is created by the receptionist, and that appointment information is also sent to the provider system. So that doctor can go ahead and take a look at that and then take further, he has the information ready about the patient. And once the patient walks in, he will go ahead and discuss the problems with the patient. Then doctor might place an order to ensure that the symptoms are concluded and to analyze the results and then go ahead and analyze the results and then go ahead and prescribe certain treatment to the patient. Right? So there will be a lab order that will be sent, lab will be sending back the results and so on. Then we have charge related info that is sent back to the receptionist so that a final charge amount can be generated and that can be sent over to the insurance company. So this is the usual workflow. Let's see where the problem arises. Now, when we talk about the data, a receptionist is sending the data in the form of HL7 to EHR. EHR is a electronic health record software. It is used by clinicians, nurses, and clinical staff to go ahead and save the patient data, save the patient's entire clinical history in that particular application. So we receive data from data from PM, which is used by receptionist. You receive data from doctors. Doctors might be sending or adding data to the EHR system. And then you have labs, which are transacting orders and results. And then you have e-prescriptions as well, which can transact through HL7 also, and also through ERX. But apparently, at the end of the day, EHR becomes a centralized data repository to store the entire data of the patient. But unfortunately, patient doesn't have access to this information, right? Even if patient wants to go ahead and try to get the access, the data is not exposed to the outside world. It is enclosed in or present in the closed ecosystem of the hospital itself. So the actual data owner is the patient, but they don't have access to their own data. So that was the problem that FHIR was trying to resolve. So what FHIR did was, now we have the EHR data, and this data needs to be exposed to the outside world. We have data coming in from various verticals, and the data is stored in the EHR system. Now, in order to make it available to the patients, and I'm talking about situation back in 2010 when FHIR was not there, or FHIR has taken birth. Um, so before that, there was no standard which could have solved this problem of exposing the data to the outside world, so that outside world can uh, interact with the actual EHR data and then make it available to the public. All right. So what FHIR did is FHIR added a layer on top of the existing database. And this layer will help us to facilitate the exchange of data from the outside systems, so that patient can go ahead and take a look at his own data if he wants to, either through mobile apps or through some desktop apps where you can send the data to the FHIR, get the data back from FHIR, right? So what happens in this process is, let's say you are a specific patient called John Doe. You will request through the mobile app that I want to see my data, and that request goes to FHIR layer. So this FHIR server layer will interact with the database, get the demographic details, allergy details, appointment diagnostics and all for this patient, and then send it back to the mobile app. The mobile app is going to show you the entire information. Okay. So this exchange is enabled with the help of this additional layer called as FHIR layer. And this type of architecture is called as FHIR facade layer. Okay, because you are adding a new code or new layer on top of your existing EHR that is already there. Okay, and how the data is exchanged? Data is exchanged in the form of JSON objects or XML objects as well. You can use JSON, XML, or Turtle, but the most famous ones is JSON. Now let's look at another solution that FHIR is providing. So in our previous situation, we were talking about an existing EHR database and adding a layer on top of that EHR database. Now in this case, in the FHIR repository server aspect, you will have a dedicated FHIR database, meaning the data from the EHR system is migrated or not migrated, or we can say the data from EHR database is converted to JSON objects and directly stored in the FHIR database. And this FHIR database again interacts with the FHIR server layer and then performs the exchange with external entities like mobile apps and desktop apps. Now, the only difference here is that this is the repository server where FHIR data is natively stored in FHIR database, which means our actual JSON objects that we want to exchange with the destination endpoint or the requester are actually stored in the FHIR database. In case of previous scenario where EHR database we were looking at, in that scenario, the data is actually stored in the form of tables. But here, we are storing them in the form of JSON objects. Okay, so that's the main difference between FHIR facade layer and FHIR repository layer. Now, it is up to the business which option they want to choose. Let's say if you talk about big applications like Epic, Cerner, Allscripts and all, they provide this layer in their system already. Okay, where user needs to interact with this layer and it will perform the exchange of data in the form of JSON and so on. Whereas there are many EHR systems who would like to take this route, or many companies, I would say, who would like to take this route. So in this, what they do is they create a data repository and convert all the data that is present in EHR to FHIR resources and store it in the FHIR database, and then make it available to the public or to the outside apps which can interact with this FHIR layer and then get the data to and fro. Okay, so what is FHIR? FHIR is stands for Fast Healthcare Interoperability Resources. So healthcare and interoperability, I think we all know. Healthcare is because we are talking about healthcare data. Interoperability is nothing but when two apps can talk to each other, they are said to be interoperable with each other. So FHIR's end goal is to make sure that we can exchange the data and make apps talk to each other. So that's why it's interoperable. And then we have FAST. FAST here is an aspiration. It's not. Uh, it doesn't mean that. It certainly means that we want to implement the interfaces faster, and it's an aspiration where the entire FHIR community wants to be in the future, so that you can spin up interfaces fastly, implement them fastly. So that's the main goal. And finally, we have resources. Everything in FHIR will revolve around resources. Okay, so we'll talk more about resources down the line. But why do we need FHIR, and what was the need that actually um, gave birth to FHIR? So one problem was what I explained in the previous slide, and it also solves the problem of whatever HL7, V2, V3, and CDA could not do at that point of time. So at that point of time, V2, V3, and CDA were specifically designed for certain use cases, and these three standards could not enable the exchange of data to the outside world. HL7, V2, V3 are used in the closed ecosystem for transactions between hospital entities only. CDA is also developed for specific purpose of document exchange. And again, that is also between hospital entities itself. Whereas FHIR uses RESTful API or RESTful web services, and it can be transacted in the form of JSON, XML, and RDF, Turtle. And these are the technologies that are already in use by the industry. So RESTful API technology was already being used for a lot of mobile app implementations and so on. So any new implementer who wants to go ahead and learn FHIR, he just has to understand the standardized structure of the resource or resources, and then understand little bit functional part of what we are doing, why we are doing, and so on. And they would be able to implement it quickly because they already know all the restful aspects of generic restful aspects of any real-time restful implementation, right? And then you have resources, which is uh, as I said earlier, these are the building blocks of the entire standard. Everything in FHIR revolves around resources, whether you talk about specifications, whether you talk about rules or conformance, everything revolves around resources. And using FHIR, entire healthcare data can be transacted in the form of simple objects. Now let's look at the evolution of these HL7 standards. So when did we start? We started back in 1997. In 1997, HL7 V3 was released. It started back in 1987 itself. Slowly, it took 10 years almost to go ahead and release that as a standard, which is version 2.3. Version 2.3 was a massive hit. Lot of the implementations were looking for certain standard like that, and it has been greatly implemented, especially in the US. Now, after that, we had version 2.5. Version 2.5 was released in 2003. These were enhancements which were needed for the future, and that was released in 2003. After that, in 2005, version 3 was released. Version 3 was not very much welcomed by the industry, especially for two reasons. Number one, uh, it was not adding much value when people convert from HL7 V2 to V3. Why? Because it is going to do the same functionality, but the structure, the design, and everything is totally different for HL7 V3. And tech competency at that point, and also number of people who want to move from V2 to V3 were very, very less because of no financial value. It's just the same thing. You are just transacting the same data, but in a different format. That's all. So that's the reason it was not very much welcomed by the industry. And today we don't see any V3 implementations anywhere. This is one of the main reason. Even if new countries are planning to digitize their data, they are still using HL7 V2 only, but not V3. Okay, but there is another standard called CDA, which was released as part of V3, and is that was really a massive hit because there was a need for that at that point of time. To exchange data between two different hospitals, there was no certain standardized mechanism, and CDA does that. So CDA was released, and then CDA was used a lot by many implementations. Next, FHIR R3, which is released in 2016. FHIR development actually started in 2010 itself, and since then they have been, I mean, the community is working. Few people are leading it. They are creating or defining the standards that are needed and all. But in 2019 is where FHIR R4 has been released, and we also had the COVID time. So that really gave a lot of traction to FHIR. Many people started using FHIR for exchanging the data between the hospitals and the outside mobile entities. And then in 2022, I guess, the Cures Act has come up, which says that patient engagement is mandatory and patient data being exposed to the app is mandatory. Okay, so that's how FHIR has been emerging, and after R4, we also had R5, which was released in May 2023, and implementations around R5 are just beginning. Most of the implementations are still working on R4 itself. Next, let's see why do we need FHIR. So HL7 organization usually defines the standards for healthcare. And as I said earlier, 2010, we did not have if we did not have any of the standards which are solving the problems or requirements that will be increasing in the future, especially in the space of web services and REST API services. So, and need for real-time data access is also increasing slowly. So, patient engagement was not seen anywhere. Mobile developments and wearable technologies were increasing, but there was no scope of reading or pushing the data to the FHIR server, to the EHR server was not possible. And then there is a vast increase in the amount and type of the source data. Existing standards V2, V3, and CDA were lacking to solve these issues. So FHIR was appealing because FHIR was using existing technologies, modern web technologies of RESTful API services, where you can exchange very specific information. Let's say, for example, I want to exchange only what are the medications of the patients or what are the insurance lists of the patient and so on. So those details will be uh, easy to exchange through FHIR. So, and FHIR also combines the best features of V2, V3, and CDA. So there are many lessons learned while during this journey of developing V2, V3, and CDA. So all of those good practices, all of those good practices are taken by HL7, and they ensure that those good things are implemented. There will be many things that are not supposed to be done. So they would go ahead and they have gone ahead and made sure that they are not repeated. One good thing is that the community and the documentation. So if you go to FHIR website, you'll get everything there. and you can read through. If you're a beginner, it will be a little tough to navigate around, but if you already have little experience, I think you can see how robust the documentation is. Um, so that is really a good thing that FHIR has come up with in terms of documentation, and also in terms of providing examples and so on for each and every resource. That is also very, very good. And especially community driven, meaning we have a FHIR community where you can talk more about issues that you have, and most of the people are active and do respond. So that is also a very good thing. Then FHIR comes in four different paradigms. Let's see what they are. First one is REST APIs. So these REST APIs are the core of FHIR standard. They help us to exchange the data using REST API protocols, either to get the data or to post the data. And you can use use the REST APIs of FHIR to perform few other additional operations like conditional creates, conditional updates, and so on. These are not purely RESTful because these are the operations that are designed by FHIR. That's one of the reasons why it is said that FHIR is loosely REST API. But REST API technology is the core where FHIR works on, or FHIR standard is built on. Second is documents. So FHIR as a standard has the plans to go ahead and replace CDA, Clinical Document Architecture Design. Okay, so that instead of new clients implementing CCD interfaces, they will go ahead and implement documents interfaces using the FHIR flavor or FHIR data resources itself. Next, you have messaging. Same reason as for documents. FHIR has plans to replace V2, V3. So standard is developed based on this particular approach as well. But it will take long time to go ahead and replace V2 because FHIR itself is evolving. It is not stagnant today. It will take more time. Uh, and until FHIR becomes stable, um, people may not go ahead and choose their HL7 V2 implementations to be done on FHIR or through FHIR, right? So people will still prefer to go with HL7 V2. So these two standards will coexist for a very long time. Um, and the last one is services. So these are any services that you want to develop. You can develop a simple service and exchange the data using FHIR standards. So these are the four paradigms. We have fifth paradigm as well, which is called a storage paradigm, which is emerging these days, which is nothing but making the data available through FHIR storage. So any questions so far? All right, I'm not hearing anything. So let us go ahead and proceed with next couple of slides. Now let us take a look at what is a resource. So in our previous slides, we have seen that FHIR is all about resources. In FHIR, resource is the basic building block, and this will help us to go ahead and design or store the entire hospital data in the form of multiple resources. So one resource is nothing but smallest unit of data set that makes some meaningful information or creates some meaningful information. Let's say patient data, patient demographic information like name, date of birth, gender, and so on. That entire data set can be called as one resource. Similarly, a patient's appointment is getting created. That appointment getting created with certain date and time for certain provider at certain department or location is one resource. So just to understand it in a better way, we can take a metaphor. We can think that there is a form. Let's say that you go to the hospital, instead of receptionist asking you, they are giving you a form and ask you to fill it up. So this form has multiple pages. First page has patient's information, or that's a template which already has uh, predefined fields. You just need to fill those blanks. You have fields for names, you have fields for address, date of birth, gender, SSN, and so on, insurance, and so on. So that's the first form. You also have a second form which you need to fill up for guarantor information. You also have third form which you want to fill up for, uh, let's say, insurance details. So there are three different forms that were given to you. Each of these forms can be considered as a resource. So we are talking about three forms here, which are nothing but three resources. Okay. Each resource will define small amount of highly focused data. And these are, the forms are generic templates only, whereas once you fill the data, they are called as instances. Apparently, you are filling three different forms. So we are talking about three different resources here. All right. So every form, usually once you fill the data, if you take a look at one form individually, then you will be able to understand that this data is about guarantor information. Let's say you are looking only at the insurance form. Then you will understand that this data is for insurance related or coverage related data, right? But you may not be able to make out complete information by looking at only one resource. Okay. So at the end of the day, usually a single resource will not talk much, but when you combine multiple resources together, then that's when you will get some meaningful information or meaningful insight into what resources are all about. Okay. So when you're taking look at a functional scenario and all, you should not look at one individual resource because that's half information. You have to combine all the resources together that would satisfy your requirement and take a look at that uh, particular functionality, or not functionality, but particular use case of understanding the data. So one single resource, if you talk patient as a resource, as an example, you may have many details like patient name, patient identifier, telephone number, address, marital status, date of birth, and so on, right? And when we talk about or take a look about this particular resource in terms of FHIR, you can see that FHIR is defining all of these elements. So as I said earlier, one resource is highly focused. Uh, it's nothing but highly focused one set of data. So here we are talking specifically about patient. So we have details about the patient only in this particular resource. We have patient name, gender, telecom. You have identifiers to transact SSN or hospital's MRN number, and so on. Right? You may be wondering why we are not seeing name with full name, like first name, last name, date of birth, first name, last name, middle initial, and so on. So in FHIR, we have these concepts of data types and all, which we'll see in the future, but apparently they are there. As you can see on the right hand side, the human name will have multiple child elements, which we call as use, text, family, and so on. Okay. So, once we start exploring the structure of FHIR resource, we'll take a deeper look at each one of these options that we have. But for you to have a summary or overview, the generic data that we see on the left-hand side can be stored in FHIR, and FHIR has already predefined a lot of structures, which are called as structure definitions, and uh, made it available. So, any questions on what a resource is? All right. I'm not hearing anything. So we will continue tomorrow. In tomorrow's session, we will take a look at the JSON structure, and also we'll take a look at JSON structure for FHIR resources, and we will deep dive into what is a domain resource, what is a base resource, what are the elements that are involved in FHIR patient object, and we'll also take a look at other things like cardinality, flags, and so on in the upcoming sessions. Okay, so if you do not have any questions, I think we can go ahead and conclude today's session here. We'll catch up tomorrow morning at the same time to continue with the training. Okay, thank you, everybody.
Thank you.